limitations of overlapping of pure orbitals in explaining the formation of some covalent molecules. Now earlier we have seen that this overlapping of pure orbitals of SS overlapping, SPZ overlapping or PZ overlapping has explained the formation of H2 or HCl or Cl2 molecule or alike molecules. Similarly, the pi bond formation of multiple bonded molecules like O2 and N2 were also being explained. Now, in fact, if I want to explain the formation of methane, which is a well-known compound, how to explain the formation of methane in the overlapping of pure orbitals? Let's see that. Carbon, which is having a configuration of 1s2, 2s2, 2p2. So, if we consider its ground state configuration according to Hund's rule, it has 2s2, 2p2 configuration. This clearly states that carbon is having two unpaired electrons, and these two unpaired electrons are only likely to be paired up. This explains the divalency of carbon. Means with this ground state configuration, the tetravalency of carbon, which is a well-known fact, cannot be explained. We have only two unpaired electrons and that has to be paired. So how could we expect the valency of 4? Further, this tetravalency of carbon could be explained by its excited state configuration, and this excited state configuration will tell that when it is little energized, the s electron, 2s electron, one of the 2s electron is migrated to the vacant 2p orbital, and thereby it is having the valence shell configuration with S1 and P3, 2S1, 2P3 configuration. This could explain the tetravalency of carbon. But how to see the formation of methane, which is a definitely well-known compound? Let's see this. In this carbon, which is having a 2s1 configuration, the pure orbital, and 2p3 configuration, that is also the pure orbital px, py and pz. Now we have 4 hydrogen. So it is expected that each hydrogen is with 1s1 electron. So it is possible that with first hydrogen and carbon we have SS overlapping over here. This is with first hydrogen. SS overlapping is quite possible. We have the second hydrogen with S and PZ overlapping, that is also possible. But the third hydrogen with S and PY is never possible. Fourth hydrogen S and PX, that is also never possible. So then how could again we explain the formation of the 4 equivalent bonds in methane? All the 4 CH bonds in methane are practically equivalent. That's an experimental fact. The X-ray diffraction methods and spectroscopic studies have revealed that the bond lengths, bond angles and all other bond parameters are same, exactly same for the CH bond, all 4 CH bonds in methane. But the formation of methane can not only be explained by the overlapping of pure orbitals. Similarly, if we consider the formation of water, so this oxygen again we will consider 1s2, 2s2, 2p4. This 2s2, 2p4 pure orbital will be like this, 1, 2, 3 and 4. The pz and py orbitals are vacant. So having 2 hydrogen, 1 hydrogen with S and pz is quite overlapping, possible sigma bond, but S and py there is no fruitful overlap. Then how could we again explain the formation of water, where again we know that OH bonds are exactly equivalent? So these are the limitations of overlapping theory, including the pure orbitals. The overlapping of pure orbital can only explain the formation of a few handful molecules, not the all molecules. Rather, most of the molecules are remain unexplained. It's their formation through the overlapping of pure orbitals. Then comes the mixing or intermixing of pure orbitals, which is known as hybridization.